Hello everyone, today I am going to explain you about my project which is malware analysis tool. So the problem statement states to design and develop a technological solution for the detection and prevention of fileless malware, a type of malicious software that uses legitimate programs to infect a computer. The solution may be in the form of a desktop or mobile application. Understanding file-based versus fileless malware attacks. File-based malware typically involves the creation and distribution of a malicious file, such as an executable file or document, that the user unwittingly downloads or opens. The malware may exploit vulnerabilities in the operating system or other software to gain access and execute its code. File-based malware is often detected by antivirus software or other security tools that scan for known malware signatures or suspicious behaviors. Fileless malware does not involve the creation or distribution of a file that can be detected by traditional antivirus software. Instead, it takes advantage of legitimate system tools and processes to inject and execute malicious code in memory. Fileless malware can be more difficult to detect and prevent because it does not rely on a malicious file that can be scanned or quarantined. Fileless malware may use techniques such as PowerShell scripts, DLL hijacking, and register keys to evade detection and persist on the system. Two common defense solutions and why they fail against file to detect fileless attacks. Antivirus software, because it relies on signature based detection to identify and quarantine known malicious file, but fileless attacks operate entirely in the memory and do not involve a file to scan for signatures. Firewalls and intrusion detection systems can only detect and block network based attacks and are not effective against fileless attacks that operate entirely within the memory of a system. So here is my approach, wherein the user gives the input memory dump, and that memory dump will be stored in AWS S3 bucket, and from there it will be accessed by Kali Linux, where I have installed a tool called Volatility 3, which will extract certain features from the memory dump and give those features to ML model, and the ML model will predict as a benign or malware. So here is the tools and technologies used. PyQt is used to create a user-friendly interface for the app, FTK Imager to capture memory dump, Volatility to extract features from memory dump, machine learning to predict from the extracted features whether it is a benign or malware. PyInstaller is used to pack the application along with FTK Imager. AWS Cloud is used to store memory dump, ML model, and Kali Linux. So here is the dataset which I am using. I got this on Kaggle. You can search for obfuscated malware 2022. This dataset is prepared on volatility 2, but I am using volatility 3 because volatility 2 does not support from the latest versions of Windows 10, and so I just need to drop this PSX view column, which is a plugin used in volatility 2, but volatility 3 does not have this plugin. And the reason for choosing this dataset, though it is built on volatility 2, is because it is a vast dataset and there is no available dataset on volatility 3. So this is my ML model, which I have made it using random forest algorithm. I got 99.99 accuracy. I'll be showing you a demo of feature extraction in my Kali Linux. So this is a bash script. On running this bash script, I got the output feature extraction successful. So this is the bash script wherein the for loop iterates through every file in my home directory and finds for these following extensions: vmem, mem, dmp, raw, which are the extensions for memory dump. And after finding that file, it will run the following plugins: pslist, dllist, handles, and output it into a .txt file. And if there is any error in outputting or running the plugin, it will raise an error flag equal to 1. And at the end, we can see that if there is an error flag equal to 1, error message will be displayed: unable to scan memory dump, try capturing memory again. And if the feature extraction is successful, we can see. And this Python volatility 3 extractor, here is the code which will convert the .txt into .json, and from that .json it will extract the features and convert it into a .csv file. So here is the output I got for running raw. I'll just run it. As you can see on running it, I got it as a malware. You can find this Crydex memory dump in Volatility Foundation GitHub page, and see it is tagged as a malware. And I still need to work on my front end and connect my front end with backend. So I'll be uploading a part 2 of this video in another 2 to 3 weeks. Thank you.